Welcome, everyone. In this video, we'll be discussing data quality remediation and exception handling at scale with Informatica, Cloud Data Governance and Catalog, Cloud Data Quality, and CLAIRE GPT. We'll start with a quick overview of the data quality lifecycle and then dive deeper into each stage, from data profiling to defining and applying validation rules, followed by data quality remediation and exception handling. Next, we'll explore the data quality monitoring process, walk through a quick demo, and finally, wrap up with a few frequently asked questions. So, let's get started and see how these capabilities help organizations manage data quality at scale. All right, let's walk through this data quality process and methodology at a high level, because this is the foundation for everything we'll discuss next, especially how Informatica help operationalize each of these steps. We start with the discovery phase. This is where we explore the data landscape, understanding what data exists, where it lives, how it flows, and what issues might already be lurking beneath the surface. Think of this as shining a flashlight into every corner of your data ecosystem. In a real-world environment, this includes profiling datasets, identifying anomalies, spotting duplicates, missing values, inconsistent formats, and understanding lineage. This step gives you the raw truth about your data's current state. Once we know what's going on, we move into define. This is where we translate business expectations into clear, measurable data quality rules and standards. Here, organizations define what good data actually means: validity rules, completeness thresholds, reference data expectations, naming conventions, and more. This step creates the blueprint for how data should behave. Once the rules are defined, the data is again assessed against these rules. Next comes apply. This is where the rules we defined are actually enforced across the data pipelines. This is the operational step, implementing transformations, cleansing logic, standardization routines, deduplication, enrichment, and validation checks. This is where data quality becomes real and actionable, not just theoretical. And finally, we reach measure and monitor. This is where we continuously track data quality over time, generate scorecards, and get alerted when something drifts out of compliance. This step closes the loop. It ensures data quality isn't a one-time project, but an ongoing discipline. Dashboards, metrics, and automated monitoring help teams stay proactive instead of reactive. You'll notice this isn't a linear process. It's a cycle. Because data changes, systems evolve, and new sources get added all the time. So we continuously discover, redefine, reapply, and remeasure to keep data quality strong. Now that we've seen the overall flow, in the next slides, I'll break down each stage in detail and show you exactly how Informatica CDGC and data quality support and automate these steps at scale. Let's dive into each one. You can only plan your data quality journey once you understand your starting point. And to do that, you first need to assess the current state of your data, what you have, where it resides, how sensitive it is, how it relates to other data, and what quality issues already exist. That's exactly where we begin, with data discovery. Think of data quality discovery as your diagnostic phase. You're essentially asking, what data do I have? Where does it live? How sensitive is it? And how serious are the quality issues? The life cycle shown on this slide is the foundation for everything we'll cover today. It starts with gathering raw statistics about your data using the data profiling capabilities in CDGC. Once you understand the shape and characteristics of the data, you can define data quality validation rules based on business requirements. These rules are created in Cloud Data Quality. Next, you apply those rules to assess the quality of the data. This can be done at scale using the DQ automation capability of CDGC. After applying the rules, the next step is to capture the failed records so they can be reviewed with the right stakeholders and remediation can be planned. CDGC's DQ remediation feature helps facilitate this process at scale. With the right stakeholders involved, data cleansing can be implemented and integrated into your ETL pipelines. Finally, CDGC's dashboarding capabilities allow you to continuously track data quality over time. And remember, this isn't a one-time exercise. Data quality discovery is a continuous, routine activity for any mature governance and quality team. Informatica's platform is designed to make every step of this cycle faster, more scalable, and easier to operationalize. Let's start with data profiling, understanding the structure and health of your data at the column level. The traditional approach means writing SQL queries table by table, column by column. That doesn't scale. CDGC flips that entirely. With one setting, enabling data profiling at the scanner level, CDGC profiles every table in your catalog in bulk. No SQL, no manual effort. And for every column, you get automatic statistics, null percentage, uniqueness, data patterns, and the most frequent values. The screenshot on this slide shows exactly how you can enable bulk data profiling with just one toggle. The result? In the time it used to take to profile one table manually, your team can now have a complete picture of your entire data estate. Once you know what your data looks like, the next question is, does it actually meet your business requirements? That's where validation rules come into play. Without a proper platform, this part can get messy fast. Teams end up writing dozens, sometimes hundreds of SQL queries just to check really basic things. Maybe a column has way too many nulls, or a field doesn't match the pattern it's supposed to. It's slow, it's tedious, and honestly, it just doesn't scale. CDGC eliminates that overhead entirely. There are two ways this process can be accelerated. First, you get pre-built DQ accelerator bundles. These are curated rule sets you can turn on right away for common data quality checks. Second, and this is the one I really want to call out, CLAIRE GPT. All you do is describe the business requirement in plain English. Literally, just say what you want. And CLAIRE GPT instantly turns that into a technical data quality rule. No SQL, no coding, nothing. CLAIRE can take hundreds of business requirements and instantly turn them into technical data quality rules, all from a single plain English prompt. And on the next slide, we'll actually walk through what that looks like in real time. So this is where you actually get to see CLAIRE GPT in action. What you're seeing here is a business user, not a data engineer, not an SQL developer, describing data quality requirements in natural language. CLAIRE GPT translates that directly into a technical rules in cloud data quality. Think about what this means for your organization. Your data stewards and business analysts can now participate directly in defining data quality standards. You remove the bottleneck of having only technical resources who can write rules. And you go from days of back-and-forth requirements gathering to rules created in seconds. This is one of the most powerful capabilities in the platform because it democratizes data quality across the entire team. Now that your rules are defined, the next step is simple. Apply them. Instead of chasing bad data manually, CDGC applies your validation rules across all your critical data elements at once, automatically. The diagram on this slide shows exactly how this works at scale. Let's walk through a quick example. Say you've created an email validation rule, either manually or using CLAIRE GPT, and you want to apply it to every email column across your entire data landscape. Here's all you need to do. Start with associating a glossary term like email address to all the email columns. Then, create a data quality rule template in CDGC and link it to that glossary term, along with the technical DQ rule you created in Cloud Data Quality. Finally, run the catalog source with the DQ automation capability enabled. And that's it. CDGC automatically maps that technical rule to every email column by generating a rule occurrence for each one. Then it executes all those rule occurrences for you. Every email column gets assessed against the email validation rule with a single click. No custom code, no manual execution, no configuring rules one column at a time. Just automated, scalable data quality assessment. This is where we move from discovery into action, remediation. When those DQ rules run, CDGC does two things automatically. First, it captures every failed record and writes it to a file location that you control, your flat file connection in the IDMC administrator. Your team can preview or download those records and fix them, all without touching production data. Second, and this is optional but very powerful, CDGC can automatically create a workflow ticket the moment a DQ score drops below your defined threshold. That ticket is routed to the right stakeholder immediately. No manual triage, no chasing people on Slack. Look at the 4 key capabilities of the data quality remediation capability. Continuous detection of DQ issues with email and in-app alerts. Auto-ticketing for failed rule occurrences and involving right stakeholders. Data preview, up to 1,000 failed records right inside CDGC. End-to-end tracking from root cause investigation all the way to validated fix. This is a complete remediation loop built into the platform. Let me show you how all of this comes together when you operate at scale. It all starts with your catalog source, where DQ remediation is enabled. You've selected a flat file connection for storing exceptions, and you've chosen a workflow to handle ticket creation. When the rule occurrences run, and if a specific DQ rule evaluates to invalid, the failed rows, the exceptions, are written in bulk to the customer-managed flat file location. If the DQ score for a data element drops below the threshold you've defined, workflow tickets are automatically created and assigned to the right stakeholders for that specific data element. And the keyword throughout this entire process is bulk. Bulk exception capture, bulk ticket creation, bulk notifications. This is what true remediation at scale looks like: automated, consistent, and built for large, complex data landscapes. Before you enable DQ remediation, there are 3 things you need to have in place. Think of these as your setup checklist. First, a flat file connection in IDMC Administrator. This is where CDGC will write the exception records for every rule run. It's a one-time configuration. Second, rule occurrences already defined on your relevant data elements. These need to exist so that when the catalog source executes, it has rules to run and exceptions to capture. Third, and this one is optional, if you want automatic workflow tickets created when scores drop below threshold, you need 2 additional things: a workflow event for data quality failure defined and enabled in MCC, and event stakeholders configured on the data elements so the right people receive and own those tickets. Get these 3 things in place, and you're ready to enable the full remediation capability. This slide shows you exactly what that workflow event configuration looks like inside MCC. The screenshot here is a sample workflow event for data quality failure ticket. Notice the key thing: You assign specific roles to this workflow event, roles like Data Steward, Data Engineer, or Source System SME. Users or groups with those roles must then be added as stakeholders on the relevant data elements. This is how CDGC knows who to route each ticket to. The assignment is role-based, which means as people move in and out of roles, the routing stays correct without any manual reconfiguration. It's a clean, auditable workflow. Every ticket has an owner. Every owner has accountability.
Now let's look at the actual switch that turns all of this on. It's a single configuration option at the catalog source level in MCC. Go to the Data Quality Configuration options for your catalog source, and you'll find the Data Quality Remediation toggle. Enable it. And from that point forward, every time that catalog source executes its rule occurrences, CDGC will automatically capture exceptions and write them to your flat file location. Optionally, you pair this with auto ticket creation, which we saw on the previous slides. But the core exception capture capability is as simple as flipping this one setting. That's the beauty of how it's designed. Powerful capability, minimal configuration overhead. Let's talk about where those exception records actually end up and how you access them. For every rule occurrence run, CDGC writes a CSV file to your configured flat file location. The file path follows a predictable pattern: connection path, catalog source, database, data source, dataset name, rule occurrence name, and execution ID. So every file is uniquely identifiable and traceable back to a specific rule and execution. At the rule occurrence level, you'll see a file path column in the total runs table. That column gives you the exact path to the exceptions file for that run, with a copy button right there. This means your data engineers can immediately pick up those CSV files, push them into their fix pipeline, and start correcting the data, with full traceability of which run produced which exceptions. One of the details I want to highlight is how tightly the ticketing integrates with the rule occurrence itself. When a failure ticket is created, you don't have to hunt for it in a separate system. It's visible directly in the Tickets tab of the rule occurrence in CDGC. So your data quality team has one place to look. The rule occurrence shows you the DQ score, the failed records file path, and the associated workflow ticket, all in context. That's a significant reduction in the amount of context switching your team has to do when investigating a data quality issue. And if you're working at the asset level, a table or a business glossary term rather than the rule occurrence directly, the same information is surfaced there too. In the Data Quality tab of any technical or business asset, the rule occurrences table now includes two new columns: File Path, which links directly to the bad records CSV, and Ticket, which links to the workflow ticket for that rule. This is important for the data owner or business stakeholder who may not navigate through rule occurrences day to day. They can go straight to the asset they're responsible for, see the DQ status, and drill directly into the exception file or the remediation ticket with a single click. One last detail on the ticketing workflow: the Changes tab. Data quality failure tickets in the Workflow Task inbox now include a Changes tab that shows exactly how the DQ score has moved over time. Not just the current score, but the delta, how much it changed and when. This is critical for validation. When your team believes they've fixed a data quality issue and reruns the catalog source, the Changes tab gives them immediate confirmation that the score has improved. No guessing, no manual comparison. The evidence is right there in the ticket. Discovery and remediation solve the problems you know about today. Monitoring is what helps you catch the new issues that show up tomorrow. CDG. CZ gives you built-in data quality dashboards that provide a continuous, organization-wide view of your data health. You can see scores across different data assets, track how things are trending over time, and quickly spot which domains or sources are starting to slip before they turn into real problems. And the best part is, users can customize these dashboards to fit their specific needs. The screenshot you're seeing here is an example of what your data governance team would typically have open as part of their daily workflow. It replaces the manual, periodic DQ reports that many teams still rely on today. And you don't have to be watching the dashboard to stay informed. When a DQ score changes, whether it improves after a fix or degrades due to a new data load, CDGC automatically sends email and in-app notifications to the relevant stakeholders. This closes the loop on the entire lifecycle. Your data owners and stewards are proactively informed the moment something changes, rather than discovering problems reactively during a business review. Combined with the exception management and DQ remediation we covered earlier, this means your organization moves from a reactive, firefighting model of data quality management to a proactive, always-on model without adding headcount.
So let's bring everything together. What Informatica's IDMC platform gives you is a complete end-to-end data quality lifecycle, from discovery all the way through to monitoring, powered by 3 tightly integrated capabilities. CDQ and CLAIRE GPT handle rule creation at scale. Your business users can describe hundreds of data quality requirements in natural language, and CLAIRE GPT instantly converts them into technical rules. No SQL, no back-and-forth translation. CDGC takes care of the heavy lifting around data discovery, remediation, and monitoring. Bulk profiling, bulk rule deployment, automated execution, exception capture, ticket creation, and continuous dashboards, all in one place. And CDI ensures that as data moves across your systems, it's cleansed and standardized right at the point of integration, so downstream applications always receive high-quality data. Together, these 3 capabilities remove the manual effort that slows data quality programs down and gives your organization the scale and automation to manage data quality as a continuous, measurable process, not just a periodic project. Thank you, and now we'll move into the demo.
To create data quality rules in bulk using CLAIRE GPT, I have documented a few DQ rules in a CSV file. You can see the rules are documented in plain English statements. There is no fixed format in which you have to define the rules. However, remember that the better you describe the rule, the better CLAIRE is going to generate an equivalent technical rule. So as a rule of thumb, try to describe the rule as clearly as you can. Navigate to the CLAIRE GPT service. Upload this file and write a prompt like, "Create DQ rules using the attached file." CLAIRE will go through the file content and generate the plan that you can see on the screen. While it generates the plan, you can click on the card to view what information it was able to extract from the uploaded file. You can see in the generated plan that CLAIRE is even going to test the rules against some sample data. Once you have reviewed the plan, you can click on or type "Yes, proceed with the plan," and then CLAIRE GPT will start working on the plan step by step. CLAIRE GPT then lists the generated technical rules and also the log. You can click on these cards to view the details. For instance, if I click on the log, it shows me the stats about the generated rules along with the testing results. I can then issue a prompt to publish these rules to CDQ. Once published, you can click on the card to view the details about the published rules. By default, the rules are generated in the CLAIRE folder under the CLAIRE project. If you want to publish the rules in any specific folder, you can include that instruction while issuing the prompt for publishing the rules. I can click on the hyperlink and it will open the rules in CDQ. Further, You can click on Explore and navigate to the CLAIRE project to view all the rules published by CLAIRE GPT. We will be able to use these technical rules anywhere in CDGC, CDP, or CDI. I have cataloged a few snowflake tables in CDGC. If I search for email, I can see there are a few columns related to email addresses. I want to apply the data quality check on these columns. The traditional way is to apply the DQ rule on each column one by one, but here we are going to use the DQ automation capability of CDGC to apply the DQ rules in bulk to all these columns. I have assigned a common glossary called email address to all these email columns. For this, you can use a bulk import template or the intelligent glossary association capability of CDGC. Next, we need to create a DQ rule template and link the email address glossary and the technical rule that was created by CLAIRE in the previous step. As the name suggests, a DQ rule template is just a template that is going to facilitate automatically applying the actual technical DQ rule on the columns. The DQ rule template will apply the technical DQ rule to all the columns that are linked with the glossary. While creating the rule template, we can specify the rule execution frequency as well. Apart from automatically applying the DQ rule to the columns, I also want to automatically capture all the failed records and generate tickets for the DQ failures. For that, we need to use the DQ remediation feature available at the scanner level. Before enabling the DQ remediation feature, we need to ensure that we have created a flat file connection in IDMC Administrator where all the failed records will be stored, and also define a workflow that will be used to create the DQ failure tickets to involve the right stakeholders. Here, I have created a simple two-step workflow to involve the data steward, followed by the source system SME when the DQ score drops and ticket is created. Let's now enable these capabilities at the scanner level. Set the Data Quality Rule Automation to Yes. Set Data Quality Remediation to Yes and select the flat file connection that was created in IDMC Admin. Set the Create Data Quality Failure Ticket to Yes. Remember, since we are instructing the scanner to generate tickets, it's mandatory that we assign all the stakeholders that we have configured in the workflow to the data element. Assigning the stakeholders to the data elements can be done as part of the scanner execution or using the bulk import template post-metadata extraction. In this case, I have assigned two stakeholders, one with the data steward role and another with the source system SME role at the scanner level itself, as we specified these two roles while configuring the workflow. The third stakeholder with the governance administrator role you see here is not going to participate in the workflow process, so you can ignore that. Post-executing the catalog source with DQ capability, navigate back to CDGC. On the rule template page, we can see it has generated 4 rule occurrences. We can see 3 of the rule occurrences have some failed records. Hence, the file path has been populated with the exception file path and the generated ticket details. Let me navigate to one of the exception file paths and show you how the exception file looks. In the exception file, you can see it contains all the source columns along with the rule name, the column name on which it was applied, and the date on which the rule ran. The stakeholders of the rule occurrences would have received email notifications and in-app notifications about tickets, so let's check that. Here, the data steward has received 3 emails, 1 for each column, and similarly, the SME has received 3 emails regarding the tickets. The email contains a link to the ticket and a link to the column on which the ticket was generated. Let me now log in as the data steward and act on the ticket. I have now logged in as the data steward, and in the notification section, I can see messages about the ticket. I can simply click on that, or I can also click on the task inbox to view all the tasks assigned to me. Here, there are 3 tasks or tickets assigned to the data steward. Clicking on the task will show the additional details about the ticket and the asset. At the top, the next actions that the stakeholder can take are highlighted. These actions are based on the steps and actions you have configured in the workflow. Let me mark the first ticket as Expected DQ Score, so the workflow loop will be closed and will not go to the next stakeholder in the workflow. Ensure you provide proper comments, as that would be helpful if anyone wants to track the actions taken by the stakeholder. Second ticket I will send to the next stakeholder in the workflow process for review and root cause analysis with the appropriate comments. Similarly, for the third ticket, let me mark it as expected DQ score. Now let me log in as the SME user, and I should only see one ticket assigned to me. Let me close the ticket with the appropriate comments. Now, if any user wants to check the DQ score, its history, and past or current tickets of a data element, they can simply navigate to the data element in CDGC, and on the Tickets tab, they can see all the resolved and open tickets. By opening the resolved tickets, they can see the actions and comments taken by the stakeholders. So overall, the DQ remediation capability helps involve the right stakeholders and facilitates the tracking and monitoring of the DQ remediation process with exception management, all at scale.
All right, now that we've completed the demo and reached the end of the session, let's take a quick look at some of the most frequently asked questions. The first question is, does scanner re-execution create another ticket if there is already an open DQ failure ticket on a data element? If a DQ failure ticket already exists for a data element and the scanner runs again, the updated DQ scores are added to that same open ticket. The scanner does not create a new ticket as long as an open one already exists for that data element. A new ticket is created only when no open ticket is present. Next question is, under what scenario are DQ failure tickets created? DQ failure tickets are created when the DQ score falls below the threshold value defined at the rule occurrence level. They are not created when the score falls below the target value. Next question is, how can I write exception records to a database? The scanner writes exception records to the customer-managed file system using a predefined folder structure. This structure cannot be replicated directly inside a database, and due to the scale of exception handling, writing exceptions straight into a database is not practical. If writing to a database is mandatory, you can build a data integration or mass ingestion process that reads the exception files from the flat file location and periodically loads them into the database. Next question is, does the scanner trigger separate tickets for each DQ rule occurrence on a data element? No. The scanner creates one ticket per data element and groups all failing DQ rule occurrences under that single ticket. You can see an example of this on the screen. Next question is, how can I enable DQ failure ticket creation even if only one record fails in a large dataset? For large datasets, a single failing record often results in a score of 99.9% in Cloud Data Governance and Catalog, which may not fall below the default threshold. To ensure a ticket is created even for one invalid record, set the threshold value of the DQ rule occurrence to 100 in CDGC. This will trigger a DQ failure ticket whenever even one record is invalid. Next question is, how can I write exception records to cloud storage such as S3? The scanner can write exception records only to a flat file connection. Here are the available options. Option 1. If Secure Agent is installed on an on-prem machine, then mount a NAS drive or file share as a local drive on the Secure Agent machine. The scanner then writes exception files directly to that mounted location. Option 2. If Secure Agent is installed on an AWS EC2 machine, then mount an S3 location as a local drive on the EC2 instance running the Secure Agent. Grant users read-only access to the S3 location so they can consume the exception files. Option 3. If the above options aren't possible, build a mass ingestion process that reads the entire folder structure from the Secure Agent file system and writes it to your preferred cloud storage. For updates on this topic, visit howdyvivek.com/202600601. Thank you for joining the session. I hope you found it helpful.